Hey everyone, this is another Autodesk Fusion 360 exam objective for the Autodesk Certified User Certification. Again, we're going to be taking a look at assembly modeling, and we're going to be looking at align and assembly joints. So this one here is going to be a pretty quick video on just kind of showing you how to put two parts together. This one here I have very simple parts, but no matter what kind of components, so you can see over here on the left side I've got a box bottom and a box side, as if I was going to create an automata box, but otherwise very simple components to be able to use to showcase this. So what they're meaning here, and as far as the align, deals with when you use the joint tool. So the joint, anytime you go through, you're going to notice one, whenever you're doing assembly, the part that's non-movable will gray out or kind of ghost out on us. And then here is our part that we have here for that we can use to move to our grounded component. So you can tell the box bottom from the little pin icon is a grounded component. So when I do this, you're going to see whenever I hover over a face, the align portion comes from what they call the joint origin or the joint origin chip. Quite often is a term that I hear used as well. So here you can choose specific points along a face, and you can see these snap points. Now, one of the easiest things to go through if you're doing this on a Windows computer, you hold the control key, that'll lock onto a face, so then that way you notice if I'm not holding onto it, as I get close to this outside edge, it may move and flip the alignment, and the green, red, and blue lines are indicating the X, Y, and Z directions. So as opposed to, you can see the orientation, how it kind of moves there. The chip is kind of lying down, kind of facing toward the top. The blue line is facing up toward the top direction, which is the Z axis in this case, also aligning with the view cube. So that kind of helps give you a little bit of an idea. Z is the blue line, X is the red, and then the green is kind of on the back side of the cube. Same kind of thing going on. So you can see this is kind of the direction that's going. Here you can see the Z direction, so the blue is kind of sticking out, going off to the right. So if you hold the control key, if you're on a Windows machine, or if you're on a Mac, you can hold the command key and that will do the same thing. So here I'm just going to make sure, one, that when I go to click, you can see if you grab a corner, the joint origin chip can flip and go in different directions. So sometimes, depending upon how a component moves, it may be because of that orientation. You want to make sure that, so like here, you can see which orientation that I have my joint origin chip working with right here. So you can see here's the y-axis, here's the X, Z is going in blue straight up like this. And then what I'm going to do is I'm going to look on my part, and what I want to make sure to have happen is that the joint origin, just like here, matches the same orientation. That chip should be moving in the same orientation. If it's faced like this, when I click, that's what's going to flip the box in the direction that I don't want it to do. So I'm actually going to go ahead and over here in my component 2, the box bottom, I'm going to hit the X on the selection, and I'm going to go through and make sure that this alignment is set up the same way. And again, I may have to, my flip direction was turned on, so if I unflip it, now I can go through and you can see that is the exact kind of orientation that I want. So again, alignment is very key and determined by that joint origin chip. So the other thing I can do here is either in the motion tab of the joint, I can choose what kind of motion, or I have this little shortcut menu that kind of pops up anytime that I have this, and I can choose what motion that I would like. So rigid is really what I want, but I can kind of see, like, is revolute one here, and I can choose what rotation, about what axis, and either I can select a custom axis if I wish, but here you can see what kind of axes that we can be able to spin this around by if we wish to look at a revolute movement. Here is slider, so there's along the Z axis, here's along the X, and here's along the Y. So, and again, the animation will play. Cylindrical is a sliding and rotational motion, so it's kind of a combination of revolute and slider. Pin slot kind of looks very similar, except for it's going to follow inside of a slot kind of motion. Planar has a movement that goes in one rotation but also sliding. And then you have the ball joint, so it rotates about the point that you specify with the joint origin chip. So those are our different types. For this particular case, I do just want a rigid joint, which will cause like a shaking animation there. And I can go ahead and say OK. So that's a little bit of a preview and a reminder of what kinds of joints and how the alignment of those joints can be created. I know sometimes for first-time Fusion users, the joint origin chip alignment can really throw them off, but the main thing is you have matching orientations with those, and then you just choose what kind of movement that you would like from those different options that you have. So that really kind of concludes how to go through and align and covers the basics of the assembly joints that are available in Fusion 360. So hopefully this helps you in your preparation for the ACU exam. If you have any questions, feel free to email me or contact me, and check out other videos spotlighting other Autodesk certified user Fusion 360 exam objectives, and in order to help prepare and make you successful in completing this exam.